Welcome to the DIY Honda Garage channel. Welcome to the troubleshooting guide for DTC P0137, which refers to the secondary heated oxygen sensor HO2S circuit low voltage issue, specifically for the Honda CRV model years 2011 through 2016. The HO2S plays a crucial role in monitoring the oxygen level in the exhaust gases, which helps the engine control module, ECM, optimize the air-fuel mixture for efficient combustion. The secondary HO2S, indicated by this DTC, generally facilitates clean exhaust emissions and engine performance. This particular DTC arises when the voltage signal from the sensor falls below the threshold expected by the powertrain control module, PCM, suggesting a malfunction either within the sensor or the wiring associated with it. The importance of accurate HO2S readings cannot be overstated, as these readings directly affect fuel economy, emissions, and overall vehicle performance. Therefore, proper diagnostics and repair are vital when this code is triggered. The DTC P0137 refers specifically to the secondary heated oxygen sensor, HO2S, designated as Sensor 2, which plays a pivotal role in exhaust monitoring. Located downstream of the catalytic converter, secondary HO2S monitors the efficiency of the converter by measuring oxygen levels in the exhaust gas. This sensor communicates with the powertrain control module, PCM, providing critical feedback that helps the engine maintain optimal combustion and reduce harmful emissions. If the sensor detects that the voltage signal drops below the specified threshold for low voltage, it triggers the P0137 diagnostic trouble code. It is important to locate the sensor precisely to conduct accurate diagnostics and repairs, keeping in mind that this low voltage can be caused by wiring issues or the sensor itself malfunctioning. Therefore, each component connected with this system must be evaluated to ensure compliance with the expected operational values. Several factors can lead to the P0137 DTC being triggered. First and foremost is a potentially faulty secondary HO2S sensor. If the sensor itself is damaged or worn out, it may send inconsistent voltage readings to the PCM, resulting in the low voltage alert. Secondly, poor connections at the sensor or the connector can also lead to unreliable signals. It's crucial to inspect these areas for any corrosion, loose terminals, or breaks in the connectors. Another possible cause is damaged wiring, especially in the circuit between the secondary HO2S and the PCM. Wiring can deteriorate over time due to environmental factors such as heat, moisture, or rodent damage. Lastly, intermittent faults may not be apparent right away, and the diagnostic equipment might indicate a temporary failure rather than a permanent issue. Understanding these possible causes helps in methodically narrowing down the issue. When the DTC P0137 is triggered, several symptoms may manifest. The first noticeable sign is the illumination of the check engine light on the dashboard, alerting the driver to an underlying issue. This warning can often lead to an increased sense of urgency for repair. Additionally, a decrease in fuel efficiency can occur due to inefficient combustion caused by faulty sensor readings. Consequently, this can also contribute to increased exhaust emissions, placing the vehicle at risk of failing emissions tests. In some instances, the vehicle may exhibit poor engine performance, such as rough idling or stalling, particularly under load. Keeping an eye on these symptoms will help in diagnosing the affected components efficiently, while also ensuring compliance with emissions regulations. In the first troubleshooting step for addressing DTC P0137, you will start by turning the ignition switch to the on position, which activates the electrical systems in the vehicle. After this, it's essential to clear any existing DTCs using the Honda Diagnostic System, HDS. This step sets a clean slate, allowing you to monitor if the issue reappears during further diagnostics. Once the DTC is cleared, start the engine and hold the engine speed at 3,000 RPM without load. Ensure the vehicle is in park or neutral. This will simulate driving conditions and allow the radiator fan to activate. After holding this condition, monitor the OBD status through the HDS to see if DTC P0137 has triggered again. If the HDS indicates failed, the issue has replicated and you should proceed to step 2. If passed, you may have an intermittent issue requiring further inspection of connections and terminals associated with the secondary HO2S sensor. In this step of troubleshooting, begin by switching the ignition to the lock position to power down the systems. Next, disconnect the secondary HO2S sensor 2 4P connector. This step is crucial for isolating the sensor from the circuit and ensuring that no current interference occurs during testing. Following this, you will need to create a test using a jumper wire between terminals A and B on the secondary HO2S 4P connector. These terminals are designated as follows: Terminal A, yellow, and Terminal B, brown. Once the jumper is in place, turn the ignition back to the on position. At this point, check the parameters using the HDS, specifically looking at the current values from the secondary HO2S. You are aiming for readings of less than 0.12 volts. If the current conditions meet this threshold, proceed to step 3 for further diagnostics. If they do not match, replace the faulty secondary HO2S sensor before moving forward with verification processes. Step 3 focuses on further diagnostics to identify the failure area. Start by turning the ignition switch to the lock position. Then, remove the jumper wire that was previously connected in the last step, ensuring the sensor is restored to its original connected state. Now, once again, turn the ignition switch to the on position to power systems up. Use the HDS to examine the values from the secondary HO2S sensor 2 under normal operational conditions, focusing on the expected voltage output, which should be around 5.0 volts. If the conditions match this threshold, proceed to the next step to narrow down potential issues further. However, if the conditions do not align, it suggests a potential short in the SO2 line or the SO2SG line, necessitating deeper investigation. Follow the diagnostic protocol to ensure accurate identification of wiring issues that could be leading to the DTC. In step 4, you will be conducting a shorted wire check, focusing on the SO2SG line. Begin by turning the ignition switch to the lock position again to ensure no electrical interference. After that, jump the SCS service control switch line using the HDS. This action will help you perform a continuity test without any interruptions. Following this, disconnect the PCM powertrain control module connector C, which has 49 pins, specifically to isolate the circuitry. At this point, check for continuity between the two designated test points. Test point 1 at PCM connector C, number 47, gray, and test point 2 at body ground. If there is continuity, this indicates a short in the SO2SG wire that needs immediate attention and repair. However, if continuity is absent, it suggests that the wiring is intact. At this point, consider updating the PCM software if it is outdated, or substituting it with a known good unit for verification purposes. Step 5 involves a similar continuity test, but this time focusing on the SO2 line. Start by once again switching the ignition to the lock position. As in the previous steps, jump the SCS line using the HDS to begin the test. Next, disconnect the PCM connector B, also with 49 pins, to effectively isolate the circuit. You will now check for continuity between test point 1 at PCM connector B, number 46, WHT, and test point 2 at body ground. Continuity at these points indicates a short in the SO2 wire that requires repair between the PCM B46 and the secondary HO2S. If continuity is not confirmed, the wiring appears to be in working condition. In this latter case, it may be advisable to update the PCM if it does not possess the latest software version, or test with a known good PCM to eliminate other potential issues. The final step in the repair verification process for DTC P0137 involves several critical actions. Start by reconnecting all previously disconnected connectors to restore the complete electrical system. Next, turn the ignition to the on position and utilize the HDS to reset the PCM. This step is important as it clears any prior error codes and allows the system to recalibrate. Following the reset, perform the PCM idle learn procedure, which helps the engine control module fine-tune its settings to the specific vehicle conditions. Next, start the engine and hold the RPM at 3000 without load until the radiator fan activates. Then allow it to return to idle. Finally, monitor the OBD status in the HDS for DTC P0137. A passed result means that the troubleshooting is complete. If failed appears, further investigation is necessary, potentially revisiting previous steps or considering PCM replacement if applicable. To mitigate the recurrence of DTC P0137 and similar issues, several preventive maintenance steps are recommended. Regular checks on the secondary heated oxygen sensor can help identify early signs of wear or malfunction before they lead to a DTC. Make it a habitual practice to inspect all associated wiring and connections for signs of wear, moisture, or corrosion. These visual inspections can prevent significant issues down the line. Additionally, regularly updating the PCM software is crucial because manufacturers release updates to resolve known bugs or efficiency improvements. Keeping the PCM updated ensures that your vehicle operates under optimal conditions without unnecessary error codes. Lastly, adopting a proactive approach regarding fuel quality and engine maintenance will ensure that the engine performance remains stable and emissions are minimized. In conclusion, DTC P0137 highlights the critical role of the secondary heated oxygen sensor in maintaining vehicle performance and emission standards. Accurate diagnostics are paramount for effective troubleshooting, allowing for a systematic approach to identify the underlying issues leading to the low voltage condition. Throughout the troubleshooting guide, we've emphasized the significance of every component in the sensor circuit, from potential wiring damage to the sensor itself. By following the outlined steps methodically, technicians can efficiently address the problem, providing quality repairs that not only resolve the current DTC, but also ensure the vehicle operates efficiently moving forward. Adopting preventive maintenance practices will further minimize the likelihood of issues reoccurring. Awareness of these elements contributes significantly to the long-term health of the vehicle and compliance with emission regulations. Please like and subscribe to the channel. See you next time.